Değerli katılımcılar ve izleyiciler, deprem yaralarını eğitimle sarıyoruz serimizin 13. günüyle bir aradayız. Seminerlerimizin tüm vatandaşlarımızın katılımına açık olduğunu bir kez daha hatırlatır, YouTube kanalımızdan da takip edebileceğinizi belirtmek isterim. Seminer serimiz kapsamında Mühendislik Fakültesi Elektrik Elektronik Bölümü öğretim üyesi Profesör Doktor Güngör Balı, Wireless Power Transfer başlıklı konuşmasını gerçekleştirmeden önce sizlerle özgeçmişini paylaşmak istiyorum. Güngör Bal, 20 Eylül 1959'da Denizli'de doğdu. BSc ve MSc derecelerini Gazi Üniversitesi'nde tamamladı. PhD çalışmasını 1994 yılında Topkapı Üniversitesi Elektrik ve Elektronik Mühendisliği bölümünde tamamladı. 1994 yılından itibaren Gazi Üniversitesi'nde öğretim üyesi olarak çalıştı. 1998 yılında doçent, 2004 yılında profesör oldu. 2022 yılı başında Gazi Üniversitesi'nden emekli oldu. Mayıs 2022 tarihinden itibaren İstanbul Topkapı Üniversitesi Elektrik Elektronik Mühendisliği bölümünde profesör olarak çalışmaktadır. Araştırma ilgi alanları elektrik makineleri, sürücüler, güç elektroniği, indüksiyon ısıtma, yenilenebilir enerji kaynaklarıdır. Ulusal ve uluslararası dergilerde ve konferanslarda yayınlanmış çok sayıda çalışması mevcuttur. Konuşmalarını gerçekleştirmek üzere Güngör Bal'ı kürsüye davet ediyorum.
Good morning, ladies and gentlemen. You are welcome. Today, I am going to speak about wireless power transfer. Thank you very much for listening to me. This wireless power transfer actually is very important in our daily life. That's my presentation outline, introduction to wireless power transfer, wired power transfer, the structure of wireless power technology, classification of wireless power technology, efficiency of wireless power technology, application, and conclusion. What is history of wireless power transmission? The Tesla predicted in 1906 the transmission of power without wires will very soon create an industrial revolution and such as the world has never seen before. And this was the beginning of wireless transmission. The wireless power transfer shows the future of freeing us from the tyranny of power cores. You know, this power cores we face every day in our life, and it occupies place. It is costly as well. That's why we want to get rid of cables. The wire power technology can provide energy for electrical and electronics device. That's important without a power cable, cord, or wire. Nowadays, the VPT is widely used in consumer electronics, electric vehicles, and implementable sensors. Wired power transfer, what is firstly, why we need the wireless power transfer? Because generally so far, we used wired power transfer. You know, it's the path of the energy, you know. We generate the energy in power station, then after we step up voltage level by using transformers. Then after high voltage transmission lines, that wire starts from here. Then after it becomes the just out of cities and to step down, using step down transform, we reduce the voltage level. And then after, by cables, we deliver this power to consumers, homes or factories or shops, you know. That's the wired situation. And especially at offices, at home, you know, now smart applications, smart homes, smart office. Now they need more cables, more sensors, and it becomes more complex. In the wired power transfer, all components are standardized and in agreement with the electrical code. You know, yes, if you use many parts in your system, they must have the standardized features, you know, and in that case, I mean, there's the voltage, frequencies, and others, you know, they must agree with others. At the end, most of our electrical devices have AC power cords. You know, we don't want it now. Wireless power technology. If we first explain what is wireless power, because you know, if a current flows through a wire or cable, it creates magnetic fields around it. That's the main idea. If, if alternating current passes through the wire, it creates varying magnetic field. If another wire comes into this magnetic fields, induction, voltage induction occurs. That's the main thing, right? Induction. For the wireless power technology, stays on induction principles. For induction, you know, from one wire, if DC current flows, what happens? It produces DC magnetic field. But it doesn't induce any voltage on another wire because it doesn't change with the time. It must change with the time. That's why to be induction, magnetic field must change with time. That's the main point. From DC source, which means we cannot produce induction voltage. Wireless power transfer makes it possible to supply power through an air gap without the need for current carrying wires. What is the place or the path for the magnetic field is air gap. In the wireless power technology, air gap plays very important role because air gap shows very big magnetic resistance to magnetic field. That's why efficiency, when you compare the wired power transfer, is lower because of air gap. VPT can provide power from an AC source to compatible batteries or device without physical connectors or wires. VPT can recharge mobile phones and tablets, drones, cars, even transportation equipment. It may even be possible to wirelessly transmit power gathered by solar panel arrays in space. You know, this Tesla's experimental device. In 1890, Nikola Tesla was able to light electric bulbs wirelessly at this Colorado spring lab using electrodynamic induction. That's the beginning of wireless power transfer. It was the three light bulbs placed 18 meters from the power source were lit, and demonstration was documented. Anyway, I will pass it. And wireless power technology uses fields created by charged particles to carry energy between transmitters and receivers over an air gap. Transmitter actually is a coil. Transmits the magnetic field, and receives another. It is coil, and it receives the magnetic field through air gap. Air gap is actually a medium, not material. It's medium. The air gap is bridged by converting energy into a form that can travel through the air. I said at the beginning, if it's DC, it can travel through the air, but you cannot use or you cannot convert it to energy because of it doesn't change with time. The energy is converted to an oscillating field, transmitted over the air, and then converted into usable electric current by receiver. Depending on the power and distance, energy can be effectively transferred via an electric field, magnetic field, or electromagnetic field waves, such as radio waves, microwaves, or even light. But in this seminar, I will especially focus on magnetic induction or magnetic wireless power technology. These are the technologies for the wireless energy transfer. If it is near, it's not far, you can use electromagnetic induction, and it has two category: electrodynamic induction, electrostatic induction. In our case, we prefer inductive coupling. Its magnetic resonance is similar, but if it is far away, kilometers or others, you use electromagnetic radiation, microwave, radio frequency power, or light or laser power. How wireless power transfer works, or what's the principle of it? You see, this is the picture. You see, there is inverter, which means you may have the AC or DC source, but you have to convert it to AC source. By using inverter supplies AC voltage or currents to transmitter coil. When the AC currents flows in the transmitter coil, it produces magnetic field, then it crosses the receiver coil, and induction happens there. That's the main idea. Then after, depends on if you want to charge your battery by using another rectifier circuit or converter circuit, you can recharge your battery, like electrical cars or others, That's the main idea. We need AC power to feed the transmitter coil, and it transmits magnetic fields, and the receiver coil gets magnetic field crossed, then after it produces again AC voltage. That's here medium is the air gap. That if there is no air gap, which means physically it will be connected physically, we don't want it. That's why air gap is very important. I said beginning, reluctance of the air gap is very high. We don't want it. We want some, sometimes it is good. It's very high reluctance. Sometimes it's not. Depends on your application. In this case, this is not information transferring. This is actually energy transferring, wireless power transfers. Various types of VPT technologies and form of power. That's a technology, inductive coupling, energy transfer method, magnetic fields, enabling the power coils of wire. That's another one is resonant inductive coupling, magnetic fields, and resonance circuits we use. Capacitive coupling, electrical fields, and energy transfer method, and conductive coupling plates. And another magnetodynamic coupling, use energy transfer through magnetic fields, and then rotating magnetic field here, and microwave radiation, and microwave technology, and phased array dishes, optical radiation, and it goes on. Comparison of the main wireless power transfer technologies: near field, non-radioactive; far field, radiative. That's the electric magnetic field, electromagnetic field, capacitive coupling, inductive power transfer, resonance inductive coupling, radio frequency energy transfer, microwaves, and laser beaming. Range. It is in the short distance we can use. In the inductive power as well, it is in short distance. Resonance inductive in the mid distance is this radio frequency for the far and laser beaming as well for the far distance. Frequency is, you see, range between hertz and megahertz here. Inductive power kilohertz, megahertz. And you see, when you go to far distances, frequency becomes gigahertz. And even for terahertz. And propagation, non-radiative, non-radiative, radiative, and radiative. Strength is very high. But here you see the radio frequency low and laser beaming high. And mobility. And here you see mobility is possible anyway. Efficiency of wireless power technologies. Efficiency parameter like performance for the wire system. Performance is very high. For wireless system, higher. It is high, but I think maybe slightly lower, but time is less. Cost for the wire system is very expensive. Cables, and especially copper, is now very expensive. Wire system has low cost, losses, moderate, average, sensitive, and reliability. Moderate to less uses, sensitivity and reliability is for the wireless system very high. That's very important. Application. Qi charging is every day. We use this technology. Now it becomes more general technology. Qi charging, an open standard for wireless charging, while some of the companies promising VPT are still working to deliver products. Computers, I say chi, but I don't know you, chi. Qi charging is standardized and devices are currently available. You see this another cell phone. Device Power Consortium, there is a consortium established in 2008, developed the Qi standard for battery charging. The standard supports both inductive and resonant charging technologies. Anyway, and they expanded it to include 15 watts now for the quick charging. Another charging for the electrical vehicles, cars, there you hear, this is the symbols of charging, It's the general symbol, but this is for the electrical cars charging. It shows this, or it uses this symbol. Inductive charging has the energy passing between transmitter and receiver coil at close range. Here there is plate here. It is transmitter actually, and there is receiver in the car. It receives the energy from the transmitter coil. That's important. Car comes on the plates. There is no physical contact. Now it becomes charged here. That's another wireless parking charge picture. This is another academic research study in Sweden. A pilot project on the holiday island of Gotland has transformed a 1.6 kilometer stretch of road into a wireless energy charging dock capable of powering a bus via a process called induction. The prepared 1.6 kilometers road for electrical car charging. When car is moving, it becomes charged. There is a video I may play later. And another application, induction cooker or induction cooking. Copper coil under the cooktop here creates electromagnetic energy. This magnetic energy interacts directly with induction compatible cookware to make it hot. Sometimes it's a cookware or it is part of this, or sometimes you put pots inside this one. But it is, I think it has successfully, I think, now it stays in the market. They are more friendly, environmentally friendly, and they have a built-in safety feature. Food cooks faster. They are easier to clean. Meal prep is easier. It can get expensive when you convert from gas to electric. This is disadvantages. It might emit a sound and more expensive. That's the advantage and disadvantages. Air quality in the induction cooker, safety, energy efficiency, heats faster and is more precise, easier to clean. Disadvantages, purchase price, scratch or break, and education. To use, you need to be trained. And conclusion, while dream of having a power delivered wirelessly for everyone's use is still far from feasible. Dream of having power delivered wirelessly for everyone's use. We wish it, but it's still far from feasible. Many devices and systems are using some forms of wireless power transfer right now, from toothbrushes to mobile phones, from cars to public transportation. There are many applications for wireless power transfer, but we need to improve or expand this application in others daily areas, we use it. These are the source. And thank you for your attention. Thank you very much. It is brief seminar, and thank you very much again for your listening. Any question? Yes?
Thank you very much, Professor, for your presentation. I have a question for you. How is the magnetic field level for the public field?
This is, is a discussion for from the beginning of electricity, It is discussed because magnetic field may harm your health or it may damage. But so far, for example, under the transmission line, if you stay under transmission line, you will become cancer or something. These things were talked, but it's not scientific results, clear scientific results. That's why, because of air gap, you said, air gap. When the air gap, becomes longer, distance becomes longer, magnetic field becomes weak. If you are very close to magnetic field, you will be crossed by magnetic field. But if you are far from magnetic field, there is no problem. Because here, there are many magnetic fields now. That's if you want to use this technology, what technology makes? It makes our life is easier, comfortable. But sometimes you pay some penalties as well. That's why it is because I have no idea about what is the decibels of this magnetic fields, but because there is standard and they are putting standards as well, there will be no problem, I think. Okay.